Today's lesson is called, do you remember factoring times in Algebra 1? And if you don't, that's okay, I'm gonna teach you. And if you're not great at it, that's also okay. This is a learning space. And if you're really good at it, huzzah, you can factor. Factoring. Okay, this is gonna feel like a really bonkers way that I'm about to do something in order, but there is a method to my madness. But I'm not really gonna explain why. Okay. There are a ton of different ways to factor. Like I said yesterday, one of them is the area method. I can't really teach it to you. I don't really get it, but it seems cool. If any of you very much want to record yourself teaching a lesson on the area method so that your fellow students can understand it, I'm very much behind you. I don't know, I'll give you extra credit. Cannot imagine what I would give it extra credit in, but I'll be like Mr. Sherry. I'll give you a pint of ice cream. That's his thing. He loves a pint of ice cream. Does he still do that?
Yeah. Yeah.
Okay, great.
He'll actually give people a pint of ice cream.
He gives you a pint. If you solve the Ben and Jerry's problems, you get a pint of ice cream. Factoring. Okay. The first method is the AC method. Hopefully this will be a really clear set of notes for everyone. If it in any way is confusing to you, set up a meeting with me. I'm happy to answer questions. The way I structure this is I tell you the generic and I give you one example. So wait, I have to get out an example that I know works because sometimes if you just make up a problem in your head, you get impossible problems. Okay, this is our example. 6x squared plus 7x minus 5. Okay, the AC method, the first thing you do is you find, AC method works for ax squared plus bx plus c. That's what you use the AC method on. First thing you do is you find a times c. Okay, first thing I do is 6 times negative 5 is negative 30. You've probably done something like this before in your life. The second thing you do is you find 2 factors of AC that add to B. Okay? So I need 2 numbers that multiply to negative 30 and add to 7. So that's 10 and negative 3. 2 numbers that multiply to 30, add to negative 7. Step 3. Are we all okay with step 1 and 2? Okay. Step 3, replace bx with blank x plus blank x from step 2. This is why I do a little example. So you write 6x squared plus 10x minus 3x minus 5. So that's the replacing. Okay, step 4, you use a form of factoring, which we're about to talk about, called factor by grouping. Factor the 4 terms by grouping. But Anna, you never taught us how to factor by grouping. I know, it's gonna be the second type of factoring I teach you, but if I teach you that one first, you just think it's dumb and not that useful and you don't remember that's really helpful here. So, factor the 4 terms by grouping. I'm going to demonstrate what that looks like, and then we're gonna talk about what the steps I did were. Factoring by grouping, you look at 2 separate groups and factor them individually. So if I were factoring 6x squared plus 10x, I would take out 2x and be left with 3x plus 5. Now I'm factoring negative 3x minus 5. I would take out a negative 1, leaving me with 3x plus 5. Now, in this whole term, I have a common term to both of them. So I take that out, 3x plus 5. Now I'm left with a 2x minus 1. So that's fully factored. Okay. That means method 2 is factoring by grouping, which I know I just explained, but I like writing out the steps as well. Okay. Factoring by grouping is different in that you use only on 4-term expressions. So you need 4 terms for factoring by grouping. Getting rid of this example 1. So, 4-term expressions. So I have to now get an example 4-term expression in the word. Let's do this one. All right, our example 1 is x to the 4th minus 2x cubed minus 8x plus 16. It's a 4-term expression. Okay. Does everyone have up through step 4? Okay. Okay, so step 1, select 2 terms and factor out their greatest common factor. Factor out their greatest common factor. It does not have to be grouped like these 2 and these 2. You can take any 2. Here, in order to show that, I'll do like first and third. So x to the 4th minus 8x. Just those 2. Their greatest common factor is x. X times x cubed minus 8. Step 2, repeat with other 2 terms. Okay? So I'm taking negative 2x cubed plus 16. They have a common factor of 2. I know they have more of a common factor. I have to leave it like this for a second. So I took out their common factor of 2. Step 3. If pieces don't match, try to factor out a negative 1. So if they don't match at all, then it might not be factorable. But if they don't match a little, like this, factor out a negative 1. 3. So that would be negative 2x cubed minus 8. I'm trying to demonstrate the mistakes that you will make at some point. Step 4. Factor out the parentheses term. Okay, imagine I said that with not an upward inflection at the end. Factor out the parentheses term. Why did I put a question mark? Okay, so we had what? X times x cubed minus 8 plus minus 2 times x cubed minus 8. So I want to factor out this common term from both of them. Get x cubed minus 8 times, we're left with an x minus 2. That's factored. Not fully factored, but it's factored. Try to factor out -1. That's often what you've done wrong. If you don't actually factor out the greatest common factor, it's definitely not going to work. So like, check to make sure that there's not like still a power of 2. Yeah.
So it would work if you did like the first two or like the first one and the last one. So
Yeah, absolutely. Yeah, if you'd get like, it'd be done in different order. Like we did this, we get x cubed times x minus 2 minus 8 times x minus 2. So you get x cubed minus 8, x minus 2. Yeah, it doesn't matter what. So in this case, trying the first and like the outside ones and the inside ones would make it a little more complicated because you'd have to see something special about x to the 4th minus 16, but it's there. Thing 3. This is not a procedure. This is just greatest common factor. Do this first. Duh. Do this first. That's thing 3. Do the greatest common factor first. If you have 2x squared minus 16x plus 32, do this, and then try and factor that inside bit. Oh, that one works. Hey, I came up with one that works. So do this, and then this. Okay. The 4th thing, oh yeah, special factors or special products. There are a few things that you should ideally visually be able to like factor immediately. Your question? Okay. So the first one is called the difference of squares. So anytime you have 2 things that are squares and they are subtracted from each other, you can immediately factor that. So like sum a squared minus sum b squared is always a plus b, a minus b. So like if you got to, if after grouping, you're left with, I don't know, x to the 6th minus 64 times x plus 5. Let's say you did factoring by grouping, you got here. Then you have to recognize that you have a difference of squares happening here. Because x to the 6th is x cubed squared, and 64 is 8 squared. So this is even more factorable into x cubed plus 8, x cubed minus 8, x plus 5. So special products are particularly useful to completely factor things. In reality, there's even further you can go. These are cubes, but we're not going to learn that just yet. Mostly because, I mean, if you want me to write it out, I'll write it out, but it's not very pretty. Like that's the full factorization. But all I want you to be able to recognize is the difference of squares. I erased this so that no one remembers that. So, the difference of squares. The other one is the square of a sum or difference. If you have something that is x squared plus 2ax plus a squared in any form. Actually, it's going to be plus or minus. That factors into x plus or minus a quantity squared. So if we had like x squared minus 4, oh wait, I'll do this one. Right there. X squared minus 8x plus 16. You could rewrite that as x squared minus 2 times 4x plus 4 squared. So that means that this is fitting in there's a squared. So that factors into x minus 4 quantity squared. Those are the special products. Tyler brought up the idea of completing the square, which is sort of factoring, but it's mostly a way to find solutions using special products. And that's called completing the square. Completing the square. Okay, completing the square. If you have, I'm just going to give a random one. X squared minus 6x plus 10 equals 7. X squared minus 6x plus 10 equals 7. There are a lot of different ways to do this. We could use the AC method and try and solve it. We could use everyone's favorite quadratic formula. Or we could use the fact that the special products gives us this nice feature. So what you do is you say, okay, x squared minus 6x plus x plus something. And we move everything else over, -3. If I wanted this to be in the form x plus or minus something squared. So if I wanted this form, so remember this term is twice that a term, right? Like we have x squared minus 2ax plus a squared becomes x minus a squared. This is the general term. So we have -2a is -6. So a is 3, right? To get that -6, we need to be plugging in 3. So this would be x minus 3 squared. If we make this x minus 3 squared so that we get that x squared and that -6x, then we're also adding 9, right? Because it would have to be x squared minus 6x plus 9. Boop. All right. I'm also going to say you would have to add 9 on both sides because you can't just arbitrarily add 9. You get x squared minus 3, x minus 3 quantity squared is 6. So x is 3 plus or minus the square root of 6. Okay. All right. Have a great afternoon. Thank you for sticking around. I will see you all tomorrow. No, wait, are you the Friday class? No, see you Monday. No.